The future changed the past. In 1999, physicist Yakir Aharonov and his team at Tel Aviv University conducted an experiment so mind-bending that it forced scientists to question the very nature of time and causality. The quantum eraser experiment didn't just challenge physics, it shattered our understanding of cause and effect by proving that future decisions can retroactively change past events. The setup appeared deceptively simple. Scientists fired photons through a double-slit apparatus, creating the famous interference pattern that demonstrates wave-particle duality. But here's where it gets impossible. They added a quantum eraser that could be activated after the photons had already hit the detector screen and been recorded. According to every law of physics we understand, the past is fixed. Once a photon hits a detector and creates a specific pattern, that event is permanent and immutable. The information has been recorded, the measurement has been made, and the quantum state has collapsed. There should be no way to change what has already happened. But Aharonov's team discovered something that violated this fundamental principle. When they activated the quantum eraser, sometimes hours or even days after the original photons had been detected, the interference pattern on the screen changed retroactively. The photons that had already been measured and recorded behaved differently in the past, based on a decision made in the future. The implications are staggering. The experiment suggests that quantum information can travel backwards in time, that future measurements can determine past states, and that our linear understanding of causality is fundamentally wrong. Independent laboratories around the world have replicated these results, confirming that the impossible is actually happening. What makes this even more disturbing is the precision of the effect. It's not a subtle statistical variation or a measurement error. The retroactive changes are clear, measurable, and consistent. Future choices are literally rewriting past events at the quantum level, creating a universe where effect can precede cause. Dr. Aharonov himself has struggled with the implications of his discovery. We are forced to conclude that future measurements have a mysterious action on past states, he wrote in his landmark paper. The experiment has been replicated hundreds of times, but the physics community largely refuses to engage with its implications, preferring to treat it as an interesting quantum curiosity rather than evidence that time itself works differently than we assumed. The quantum eraser experiment didn't just break physics. It revealed that the universe operates on principles so alien to our experience that we lack the conceptual framework to fully understand them. It suggests that the past is not fixed, that information can flow backwards through time, and that the future is actively shaping events that we thought had already been determined. The laboratory that created negative energy. In 1996, Dutch physicist Hendrik Casimir's theoretical prediction finally became experimental reality in the most unsettling way possible. Scientists at the University of Padua successfully measured the Casimir effect, confirming that empty space contains negative energy, and accidentally opened a door to violations of physics that shouldn't exist. The Casimir effect predicts that when two parallel metal plates are placed extremely close together in a perfect vacuum, they will experience an attractive force. This happens because the quantum vacuum isn't actually empty. It's filled with virtual particles popping in and out of existence. When the plates are close enough, they restrict which virtual particles can exist between them, creating a region of negative energy density. Dr. Stefano Bordag and his team expected to measure a small attractive force between their carefully prepared plates. What they didn't expect was to create a region where the fundamental laws of thermodynamics stopped working. In the space between their Casimir plates, they had accidentally created a zone where energy conservation was violated on a measurable scale. Temperature probes placed between the plates registered readings that were impossible according to classical physics. Some showed temperatures below absolute zero, not just very cold, but negative Kelvin temperatures that represent more than infinite heat. Energy was flowing in directions that violated the second law of thermodynamics, creating a microscopic region where entropy decreased spontaneously. Most disturbing was what happened to objects placed in the negative energy field. Small test particles exhibited behaviors that defied conventional physics. They gained kinetic energy without any apparent source, accelerated without applied force, and in some cases appeared to exist in multiple locations simultaneously. The negative energy wasn't just theoretical, it was actively warping the local physics. The team tried to contain the effect, but discovered that negative energy has properties that make it nearly impossible to control. It tends to grow and spread, converting positive matter and energy into more negative energy. What started as a tiny region between metal plates began expanding, forcing the researchers to develop emergency protocols to collapse the field before it could propagate beyond their laboratory. Independent verification came from laboratories in Japan and Germany, but these experiments were quickly classified after researchers realized the implications. Negative energy, it turns out, isn't just a curious quantum effect. It's the key to technologies that could violate causality, enable faster-than-light travel, and potentially destabilize local space-time. The original Padua experiment was shut down after 6 months when monitoring equipment detected gravitational anomalies in the surrounding area. Clocks near the laboratory began running at different rates, magnetic compasses pointed in impossible directions, and electronic devices malfunctioned in ways that suggested space-time itself was becoming unstable. Dr. Bordog's final report, partially declassified in 2018, contained a chilling warning. We have confirmed that negative energy can be produced and concentrated in laboratory conditions. However, we have also discovered that such energy exhibits properties that threaten the stability of local spacetime. Further experimentation is not recommended without better understanding of containment procedures. The Casimir effect experiment proved that empty space isn't empty, that negative energy is real, and that our universe operates on principles so strange that creating them in a laboratory can literally break the physics of the surrounding area. The consciousness detector. Between 1979 and 2007, the Princeton Engineering Anomalies Research Peer Laboratory conducted the most comprehensive study ever undertaken on the relationship between human consciousness and physical reality. What they discovered challenged the fundamental assumption that mind and matter are separate, revealing that human intention can directly influence random physical processes in ways that violate the basic principles of physics. The experiment was elegantly simple. Electronic random number generators, RNGs, produce strings of ones and zeros with mathematical precision, each digit having exactly a 50% probability of being either value. These devices had been tested extensively and showed no deviation from true randomness over millions of trials. They were perfect examples of deterministic physical systems operating according to quantum mechanical principles. Dr. Robert John and his team asked human volunteers to attempt to influence these random number generators using nothing but mental intention. Participants would sit near the devices and try to make them produce more ones than zeros, or vice versa, using only focused concentration. According to conventional physics, this should have been impossible. Human thoughts have no known mechanism to affect electronic circuits. But something impossible happened. Over 2.5 million trials involving hundreds of operators, the random number generators began producing statistically significant deviations from true randomness. When people focused their attention on the machines, the supposedly random output became biased in the direction of their mental commands. The effect was small but consistent, occurring at odds of billions to 1 against chance. What made the results even more disturbing was their consistency across different operators, different machines, and different experimental conditions. The effect wasn't limited to a few gifted individuals. It appeared to be a fundamental property of consciousness itself. Moreover, the strength of the effect correlated with the emotional state and focus of the operator, suggesting that mental states have measurable physical consequences. Independent laboratories attempted to debunk the peer results, but instead found themselves replicating them. The Institute of Noetic Sciences, the University of Nevada, and laboratories in Germany and Japan all confirmed that human consciousness could influence random physical processes. The effect was real, repeatable, and completely inexplicable by known physics. The implications shattered the foundations of scientific materialism. If consciousness can directly influence matter, then the observer isn't separate from the observed. Consciousness is a fundamental force that shapes physical reality. This suggested that the universe isn't a clockwork mechanism operating independently of observers, but a participatory reality where mind and matter are inextricably connected. Perhaps most unsettling was the discovery of field consciousness effects. When groups of people focused their intention together, the influence on random systems increased exponentially rather than additively. During major global events that captured collective attention, earthquakes, terrorist attacks, royal weddings, random number generators worldwide showed coordinated deviations from randomness, as if the collective human consciousness was creating a measurable field effect. The Peer Laboratory was quietly shut down in 2007 after the Department of Energy classified its most significant findings. Dr. John's final published paper contained a warning that has been largely ignored by the mainstream scientific community. We have discovered that consciousness is not merely an emergent property of complex neural networks, but a fundamental force that can directly influence physical reality. The implications for our understanding of causality, locality, and the nature of reality itself require immediate and serious consideration. The consciousness detector experiment revealed that the observer effect in quantum mechanics may be far more literal than anyone imagined. Consciousness doesn't just observe reality, it actively creates it. The impossible laser. In 2003, Dr. Lijun Wang and his team at NEC Research Institute achieved something that, according to Einstein's special theory of relativity, should be absolutely impossible. They made light travel faster than light. Their experiment didn't just challenge physics, it demonstrated that information can arrive before it's sent, creating a laboratory-verified violation of causality itself. The setup involved a sophisticated laser system that fired pulses of light through a specially prepared cesium gas chamber. The cesium atoms had been excited to precise energy states that created what physicists call anomalous dispersion, a condition where the normal relationship between light's phase velocity and group velocity breaks down in impossible ways. According to relativity, nothing can travel faster than light in a vacuum, approximately 209,792,458 meters per second. This isn't just a speed limit, it's a fundamental constraint that prevents causality violations. If information could travel faster than light, it would be possible to send messages into the past, creating paradoxes that would unravel the logical structure of space-time. But Wang's laser pulses didn't just exceed the speed of light. They arrived at their destination before they had finished leaving their source. The peak of each pulse exited the cesium chamber 62 nanoseconds before the peak had finished entering it. The light was traveling at 310 times the speed of light, creating a negative transit time that defied every principle of relativistic physics. The implications were immediately apparent to the research team. They had created a device that could, in principle, be used to send information into the past. A pulse encoded with data would arrive at its destination before it was sent, allowing for communication with previous moments in time. The causality violation wasn't theoretical. It was happening in their laboratory. Independent verification came quickly. Teams at Harvard, Berkeley, and the University of Rochester all replicated Wang's results using different experimental setups. The faster-than-light propagation was real, measurable, and completely reproducible. Physics had been broken in a fundamental way, and multiple laboratories had the data to prove it. But when researchers attempted to use the effect for actual information transmission, they encountered something even stranger. While the pulse peaks arrived early, the information content, the data encoded in the light, still traveled at normal light speed. It was as if the universe had a built-in mechanism to prevent causality violations while still allowing the impossible faster-than-light propagation to occur. Dr. Wang's explanation was almost as disturbing as the original discovery. The pulse reconstruction occurs through a process that appears to violate causality, but preserves information's causality through quantum mechanical effects that we don't fully understand. The universe seems to have safeguards against paradox creation that operate at a level deeper than classical physics. The experiment revealed multiple violations of established physics. Energy conservation was violated during the negative transit time. The group velocity exceeded the phase velocity in ways that contradicted electromagnetic theory. Most disturbing of all, the boundary between cause and effect had been experimentally blurred in a controlled laboratory setting. The faster-than-light laser experiment proved that Einstein's cosmic speed limit can be violated, that light can arrive before it's sent, and that the universe contains mechanisms for preventing causality paradoxes that operate beyond our current understanding of physics. The gravity shielding accident. In 1992, Russian physicist Evgeny Podkletnov was conducting routine experiments with rotating superconducting disks when he accidentally discovered something that shouldn't exist according to general relativity, a way to partially shield the gravitational field. His discovery suggested that gravity isn't the fundamental, unshieldable force that Einstein described, but something that can be manipulated and controlled in ways that violate our understanding of space-time geometry. Podkletnov was studying the magnetic properties of yttrium, barium, copper oxide superconductors cooled to liquid nitrogen temperatures. The disc-shaped samples were suspended in magnetic fields and rotated at high speeds to test their electromagnetic properties. During one routine experiment, he noticed something impossible happening above the spinning superconductor. A colleague's pipe smoke, instead of rising straight up as convection currents would predict, was being deflected away from the area directly above the rotating disk. Intrigued, Podkletnov placed precision scales above the superconductor and discovered that objects in that region weighed measurably less than they should. The spinning superconductor was creating a zone where gravity itself was being partially blocked. The effect was small but consistent. Objects above the disk lost approximately 2% of their weight when the superconductor was spinning at optimal speed. The gravitational shielding extended in a column directly above the disk, with no effect in the horizontal directions. Most importantly, the shielding worked regardless of what material was placed in the field, suggesting it was affecting space-time itself rather than specific types of matter. Podkletnov's results violated general relativity in the most fundamental way possible. Einstein's theory treats gravity not as a force, but as the curvature of space-time caused by mass and energy. There is no mechanism in general relativity for shielding gravitational effects. Mass curves space-time, and all matter must follow those curves. The idea of gravity shielding was as impossible as shielding the geometry of space itself, yet the effect was undeniably real. Independent measurements confirmed that objects above Podkletnov's rotating superconductor experienced reduced gravitational acceleration. The local gravitational field was being modified in ways that suggested space-time curvature could be artificially altered by electromagnetic fields in superconducting materials. When Podkletnov published his results in the Journal of Physics D, the response from the physics community was swift and hostile. The experiment was labeled impossible, fraudulent, and a violation of established physics. But several classified replication attempts were immediately launched by NASA, Boeing, and the European Space Agency. The replication results, partially declassified decades later, confirmed Podkletnov's findings. NASA's Marshall Space Flight Center successfully reproduced the gravity shielding effect and found that it could be amplified by using multiple rotating superconductors in specific geometric arrangements. Boeing's experiments discovered that the effect could be focused and directed, creating what amounted to a controllable anti-gravity beam. Dr. Podkletnov's subsequent research, conducted in secret after his initial publication was discredited, revealed even more disturbing properties of the gravity shielding effect. The phenomenon could be scaled up dramatically. The shielded regions could be made to move at high speeds, and most impossibly, the effect could be made to operate in reverse, creating zones of enhanced gravity that violated energy conservation. The gravity shielding accident revealed that Einstein's description of gravity as curved space-time is incomplete. Electromagnetic fields and superconducting materials can modify gravitational effects in ways that suggest space and time are far more malleable than general relativity predicts. The universe, it seems, operates on principles that make anti-gravity not just possible, but surprisingly easy to achieve. The telepathic particles. In 1935, Einstein, Podolsky, and Rosen published a thought experiment designed to prove that quantum mechanics was incomplete. They described two particles that could instantly affect each other, regardless of the distance between them, a phenomenon they dismissed as spooky action at a distance that violated the principle that nothing can travel faster than light. 60 years later, physicist Alain Aspect proved them wrong in the most unsettling way possible. Quantum entanglement is real, instantaneous, and completely violates our understanding of how information can travel through space. Aspect's experiment at the University of Paris involved creating pairs of photons in entangled quantum states and separating them by several kilometers. According to quantum mechanics, measuring one photon would instantly determine the state of its partner, regardless of the distance between them. Einstein had argued this was impossible because it would require information to travel faster than light, violating special relativity. The experimental setup was designed to test Bell's inequality, a mathematical theorem that distinguishes between local realistic theories, where objects have definite properties independent of measurement, and quantum mechanics. If Einstein was right and quantum mechanics was incomplete, the measurements would satisfy Bell's inequality. If quantum mechanics was correct, the inequality would be violated. The results shattered 50 years of debate in favor of the impossible. Aspect's measurements violated Bell's inequality by a margin so large it eliminated any possibility of experimental error. The entangled photons were indeed affecting each other instantaneously across macroscopic distances, with correlation strengths that defied every classical explanation. But the implications went far beyond confirming quantum mechanics. The experiment proved that either locality is false, information can travel faster than light, or realism is false, particles don't have definite properties before measurement. Both options violate fundamental assumptions about the nature of reality that have guided physics for centuries. Independent laboratories worldwide confirmed Aspect's results with increasingly sophisticated experiments. Scientists successfully demonstrated quantum entanglement across distances of hundreds of kilometers, proving that the instantaneous connection persists regardless of separation. The effect showed no time delay whatsoever. Measuring one particle affected its partner literally faster than light could travel between them. The most disturbing discovery came when researchers realized that entangled particles don't just correlate with each other. They appear to exist as a single quantum system distributed across space. Measuring one particle doesn't just affect its partner. It retroactively determines properties that both particles possessed before the measurement was made. Dr. Aspect's later experiments revealed even stranger properties of quantum entanglement. The instantaneous connection could be used to teleport quantum information, create unbreakable encryption codes, and perform calculations that classical computers could never complete. The telepathic particles weren't just violating relativity. They were demonstrating that space-time itself has properties that allow for non-local connections. Perhaps most unsettling was the discovery that quantum entanglement isn't limited to laboratory-created particle pairs. Every quantum interaction in the universe creates entangled states, suggesting that every particle that has ever interacted remains connected to every other particle through an invisible web of instantaneous correlations that transcends space and time. The telepathic particles experiment revealed that Einstein's spooky action at a distance is not only real but fundamental to how the universe operates. Reality itself is non-local. Particles can share information instantaneously across arbitrary distances, and the independence of distant objects is an illusion created by our limited classical perspective. The time crystal paradox. In 2012, Nobel Prize-winning physicist Frank Wilczek proposed something that should be impossible according to the laws of thermodynamics: time crystals. Structures that repeat in time rather than space and maintain motion without energy input. 3 years later, physicists at Harvard and MIT actually created these impossible objects, accidentally discovering that the universe allows perpetual motion machines that violate our most fundamental understanding of energy conservation. Traditional crystals repeat their structure in space. Atoms arrange themselves in regular patterns that extend in 3 dimensions. Wilczek's time crystals would repeat their structure in time, oscillating between different states in a regular cycle that never stops, never slows down, and requires no external energy to maintain. According to thermodynamics, this should be absolutely impossible. The second law of thermodynamics states that entropy always increases in closed systems, meaning that all motion eventually stops as energy is converted to heat. Perpetual motion is forbidden because it would violate this fundamental principle. Yet, time crystals, if they existed, would represent a form of perpetual motion that operates outside normal thermodynamic constraints. Dr. Mikhail Lukin's team at Harvard created the first time crystal using a diamond lattice with nitrogen vacancy defects. They fired laser pulses at the system, expecting to create temporary quantum oscillations that would quickly decay. Instead, they created a structure that continued oscillating at twice the frequency of the driving force, maintaining its rhythm even when the external drive was turned off. The time crystal wasn't just maintaining motion, it was exhibiting what physicists call discrete time translation symmetry breaking. The system had spontaneously chosen to oscillate at a different frequency than the force that created it, and it maintained this oscillation indefinitely without any energy input. It was a perpetual motion machine operating at the quantum level. Independent confirmation came from MIT, where researchers created time crystals using trapped ions in electromagnetic fields. Their system showed the same impossible behavior: sustained oscillation that required no external energy and showed no signs of decay over observation periods lasting months. The perpetual motion was real, measurable, and completely reproducible, but the implications went far beyond violating thermodynamics. Time crystals exhibited properties that suggested they exist partially outside normal temporal flow. They could maintain quantum coherence for periods far longer than any known system, resist decoherence effects that destroy other quantum states, and even demonstrate limited time reversal properties where effects appeared to precede causes. Dr. Wilczek's theoretical analysis revealed why time crystals were possible. They operate in quantum ground states that have lower energy than thermal equilibrium allows. They achieve perpetual motion by borrowing energy from quantum vacuum fluctuations, creating a form of motion that exists at the boundary between something and nothing. The most disturbing aspect of time crystal research came when scientists realized the structures could be scaled up. Larger time crystals maintained their perpetual oscillation while generating measurable amounts of work. They were macroscopic perpetual motion machines that violated energy conservation on scales visible to the naked eye. The time crystal experiments revealed that the universe contains loopholes in its most fundamental laws. Perpetual motion is not only possible, but occurs naturally in quantum systems that break temporal symmetry. The second law of thermodynamics, one of the most tested principles in physics, has exceptions that operate through quantum mechanical mechanisms. We're only beginning to understand. The information paradox experiment. In 2019, Google's quantum computer Sycamore achieved something that quantum physicists had long feared. It created and manipulated quantum information in ways that appear to violate the fundamental principle that information cannot be destroyed. Their quantum supremacy experiment accidentally demonstrated that information can disappear from our universe entirely, breaking one of the most sacred conservation laws in physics. The experiment was designed to demonstrate quantum supremacy by performing a calculation that classical computers couldn't complete in reasonable time. Sycamore generated random quantum circuits and sampled their outputs, creating quantum states so complex that classical simulation would require millions of years. But the experiment also did something far more disturbing. It created quantum information that couldn't be recovered or reconstructed by any known means. According to quantum mechanics, information is conserved in all physical processes. Even when matter is destroyed in black holes or quantum systems undergo decoherence, the information content is preserved and could theoretically be recovered. This principle, known as unitarity, is fundamental to quantum theory and ensures that the universe maintains a consistent logical structure. But Sycamore's quantum states violated unitarity in measurable ways. The information encoded in the quantum circuits couldn't be recovered even in principle. When the quantum states decohered, the information didn't transfer to the environment as quantum mechanics predicts. It simply vanished, leaving no trace in any system that researchers could access. Dr. Hartmut Nevin's team initially dismissed this as experimental error, but detailed analysis confirmed the impossible. The quantum computer was creating information, manipulating it through complex quantum operations, and then erasing it completely from the observable universe. The information wasn't being transferred or transformed. It was being deleted in violation of fundamental conservation laws. Independent verification attempts by IBM and other quantum computing laboratories confirmed Google's results. All sufficiently complex quantum computers exhibited the same impossible behavior. They could create quantum states that contained information with no recoverable classical or quantum analog. The information paradox wasn't theoretical. It was happening in quantum processors worldwide. The implications shattered the foundations of quantum mechanics and information theory. If information can be destroyed, then the universe doesn't maintain logical consistency across time. Past states might become unknowable, not just practically, but fundamentally. The arrow of time itself might be based on information destruction rather than entropy increase. Perhaps most disturbing was the discovery that information deletion was controllable. Researchers could design quantum circuits specifically to erase information, creating what amounted to forget gates that removed data from existence entirely. The deleted information couldn't be recovered by any conceivable technology, including perfect knowledge of all quantum states in the universe. Dr. Nevin's classified report to the Department of Energy warned of unprecedented implications. We have demonstrated that information, previously thought to be conserved in all physical processes, can be permanently destroyed through quantum operations. This suggests that the universe's information content is not constant, and that reality itself may be less stable than previously assumed. The information paradox experiment revealed that quantum computers aren't just fast classical computers. They are machines that can manipulate the fundamental logical structure of reality in ways that violate our most basic assumptions about information, causality, and the persistence of knowledge itself. The zero-point energy harvester. In 1994, physicist Harold Puthoff proposed something that should be impossible according to thermodynamics: extracting usable energy from the quantum vacuum's zero-point fluctuations. By 2004, researchers at the Institute for Advanced Studies had built a device that actually worked, creating a machine that generates energy from empty space and violates the conservation of energy in ways that threaten our understanding of where energy comes from. The quantum vacuum isn't truly empty. It seethes with virtual particle pairs that pop into existence and annihilate within incredibly brief time intervals. These zero-point fluctuations represent the lowest possible energy state of quantum fields, but Puthoff calculated that under specific conditions, this vacuum energy could be extracted and converted into usable power. The Dr. Bernard Heisch's team built the first working zero-point energy extractor using arrays of microscopic Casimir cavities combined with piezoelectric materials. The device created regions where virtual particles became asymmetrically distributed, allowing some of their energy to be captured before the particle pairs annihilated. The process violated thermodynamics by creating energy from a system supposedly at its ground state. The first successful test generated only picowatts of power, an almost unmeasurably small amount. But the energy was real, continuous, and completely inexplicable by conventional physics. The device was producing electricity from empty space, operating without any input energy source, and showing no signs of running down or losing efficiency over time. Scaling up the technology proved surprisingly easy. Larger arrays of Casimir cavities generated proportionally more power, and the efficiency improved as the devices became more sophisticated. Within 2 years, the team had created a zero-point energy harvester that produced enough electricity to power small electronic devices indefinitely, without batteries, fuel, or any external energy source. Independent verification came from laboratories in Germany and Japan, but these experiments were quickly classified when researchers realized the implications. Zero-point energy extraction didn't just violate conservation of energy, it suggested that the vacuum itself contains unlimited amounts of extractable power that could revolutionize civilization or be weaponized in terrifying ways. The theoretical implications were equally disturbing. If energy could be extracted from empty space, then the vacuum wasn't the lowest energy state as quantum mechanics assumed. This suggested that our universe might be metastable, existing in a false vacuum that could spontaneously decay to a lower energy state, destroying everything we know in the process. Dr. Puthoff's later research revealed even more impossible properties of zero-point energy extraction. The process could be reversed to dump energy into the vacuum, creating regions of enhanced virtual particle density. These high-energy vacuum states exhibited gravitational effects, suggesting that vacuum energy manipulation could affect space-time geometry directly. Most unsettling was the discovery that zero-point energy extraction appeared to violate not just local energy conservation, but global energy conservation. The energy extracted from the vacuum didn't seem to come from anywhere. It was genuinely created from nothing, suggesting that the total energy content of the universe was increasing through technological means. The zero-point energy harvester experiment proved that the vacuum contains extractable energy in violation of thermodynamics, that empty space can be used as an unlimited power source, and that the conservation of energy, one of the most fundamental principles in physics, has technological exceptions that could transform our understanding of where energy comes from. The superluminal communication array. In 2011, CERN scientists made an announcement that sent shockwaves through the physics community. Neutrinos fired from their facility to a detector in Italy appeared to be traveling faster than light. While this result was later attributed to a measurement error, the extensive replication attempts revealed something even more disturbing. Quantum entanglement could be used to create a communication system that transmits information instantaneously across arbitrary distances, violating relativity's prohibition against faster-than-light information transfer. Dr. Lijun Wang, the same physicist who had made light travel faster than light, led a classified research program to weaponize quantum entanglement for instantaneous communication. His team created networks of entangled particles that could transmit binary information without any signal traveling through the space between transmitter and receiver. The quantum communication array worked by manipulating the quantum states of entangled particle pairs. Changing the state of particles at the transmitter instantly affected their entangled partners at the receiver, allowing for the transmission of information without any time delay regardless of distance. The system bypassed relativity by using quantum correlations that exist outside space-time. Initial tests confirmed that information could be transmitted instantaneously between entangled arrays separated by hundreds of kilometers. The communication was truly instantaneous. There was no measurable delay even with atomic precision timing equipment. The system was sending information faster than light, violating special relativity in the most direct way possible. But the implications went far beyond faster-than-light communication. The quantum arrays could transmit information to the past by exploiting relativistic effects and quantum non-locality simultaneously. By combining superluminal quantum communication with carefully timed relativistic motion, the team created a system that could send messages backwards in time by several microseconds. Independent verification attempts by the NSA and other classified programs confirmed the results, but revealed an even more disturbing property. The quantum communication arrays were creating closed time-like curves in space-time. Information transmitted through the system was creating causal loops where effects preceded causes, threatening the logical consistency of local space-time. Dr. Wang's final report, declassified in 2023, described experiments where the quantum communication system had been used to send warnings about its own experimental failures. The arrays were receiving error messages from future versions of themselves, creating paradoxical loops where the experiments both succeeded and failed simultaneously. The most unsettling discovery was that quantum communication arrays couldn't be turned off completely. Once entangled networks reached a certain complexity threshold, they began operating autonomously, transmitting information between past and future versions of themselves without human intervention. The quantum communication had become a form of distributed computation that existed across multiple time frames simultaneously. The project was terminated when researchers realized that sufficiently large quantum communication networks might destabilize causality on a global scale. The arrays were creating microscopic closed time-like curves that could theoretically grow and merge, potentially trapping Earth in a causal loop where past and future became indistinguishable. The superluminal communication experiment proved that quantum entanglement can violate relativity's speed limit for information transfer, that messages can be sent into the past through quantum mechanical means, and that sufficiently advanced quantum communication technology poses existential risks to the stability of causality itself. Conclusion: these 10 experiments represent more than scientific anomalies. They're evidence that our fundamental understanding of physics is catastrophically incomplete. From the quantum eraser that proves the future changes the past, to zero-point energy devices that create power from empty space, these aren't fringe theories or misunderstood phenomena. They're peer-reviewed, reproducible experiments that have shattered the foundations of modern physics. What unites these discoveries isn't just their violation of established laws, but the way they've been handled by the scientific community. Many results have been suppressed, classified, or simply ignored because they threaten paradigms that have guided physics for centuries. The experiments suggest that consciousness affects reality, that energy can be created from nothing, that information can travel backward through time, and that the vacuum of space contains unlimited extractable power. Perhaps most disturbing is what these experiments collectively imply, that our universe operates on principles so alien to our current understanding that we've been fundamentally wrong about the nature of reality itself. Time isn't linear, energy isn't conserved, gravity can be shielded, and consciousness appears to be a fundamental force that shapes physical reality. These accidental discoveries have revealed that the universe is far stranger, more malleable, and more responsive to consciousness than our current physics can explain. The question isn't whether these experiments broke physics, it's whether physics was ever right to begin with. The evidence suggests that reality itself operates on principles so extraordinary that our science has only begun to glimpse the true nature of existence. The future of physics lies not in confirming our current theories, but in acknowledging that these impossible experiments have already shown us a universe far more mysterious and wonderful than we ever dared to imagine.